there, math analyzers, and welcome to your Chapter 5, Lesson 4, Day 2 notes. We are going to continue to rationalize our complex numbers, our imaginary numbers. You can't have an imaginary number in a denominator. You can't have a radical in a denominator. And an imaginary number is the square root of 1 under a radical. So, hence, you can't have an I in a denominator, right? Let's first remind ourselves what conjugates do. Now, conjugates of complex numbers are same terms with a different sign in the middle, right? So if I have 4 plus 2i, 4 minus 2i is its conjugate. If I have 3 minus 5i, 3 plus 5i is its conjugate. If I have 15 plus 7i, 15 minus 7i is its conjugate. So I always pick on the middle sign to change, just change one sign, and you've got conjugates, right? And the cool thing about conjugates is that when you FOIL a conjugate pair, they come out to an integer. The actual imaginary units cancel out because this is really the same thing as dots, difference of two perfect squares, right? So let me just show you that, and then I'll show you in the graphing calculator. 4 times 4 is 16. 4 times negative 2i is negative 8i. 2i times 4 is positive 8i. See, there it is. Opposite signs of the same value. So they're opposites. They cancel each other out to 0. And then you have 2i times negative 2i. That's a negative 4i squared. Well, what's an I squared actually equal to? Negative 1. So I know I just replace I squared with negative 1. Negative 4 becomes positive 4. 16 plus 4 is 20. So there you have it. It comes out as an integer. And again, we'll just show how you can multiply conjugates together. Oops, other direction, right? Because my video is opposite of which. Here we go. My video is opposite what I'm actually experiencing right here. All right, here we go. 3 minus, I was doing the 4, right? So 4 plus 2i times 4 minus 2i. So two conjugates multiplying together, and boom. You can just square the front number, square the back number, and add them. So 4 squared is 16, and 2 squared is 4. 16 plus 4, 20. That's how it really ends up working. So I could try that here, right? Let's try it here. 3 squared is 9. 5 squared is 25. 9 plus 25 is 34, right? So let's try that. 3 minus 5i and 3 plus 5i is 34. There we go. And last but certainly not least, right? I don't want you guys to try and square 15 in your head and add that with 7, right? Don't want your brains to explode. Oh, no. There we go. Which makes sense because 15 squared is 225. 7 squared is 49. Add them up. There we are. So what that means is if you end up with a complex number, an a plus bi form in a denominator, what that tells me is that I'm going to have to multiply top and bottom of a fraction with that in it, with a binomial in its denominator, by its conjugate, just like we did in chapter 4. It was chapter 4, lesson 6 that we did that in, but that's the reason we have to do that. So here's your rationalization in words. Feel free to read, but the far more important part about this right here is the joke. Come on. Look, 2 and 3, they look at 8. 8, guys, want to meet my new friend? And they're 2 and 3, they're like, sure, where is he? He's right here. Why can't anyone else see you? Beats me. He's his imaginary friend, guys. Telling you, they're just awesome in this chapter. All right, anyway. Okay, so This is what I mean by a binomial denominator in a plus bi form, right? You can see that there's an I in a denominator. It can't stay because an I is a radical, and radicals can't stay in a denominator, so we call it rationalizing. So what I do is I look at that denominator and I say, okay, I need to know its conjugate, because if I know its conjugate and I multiply it by its conjugate, I get an integer in the denominator. Okay? So the conjugate of 1 plus 2i is 1 minus 2i. Now, anything I do to a denominator multiplying wise, I also have to do the numerator. So that's where it might get sticky. Now, I, in my procedure, of course, showed you each and every step typed out, but we do know that we can multiply using our graphing calculator. Okay, so since we know that, we can use our graphing calculator to do things. So that's what I would recommend doing. Let's actually do that together down here. Okay, so in exercise 3, let's look at A. We see 3 plus 4i down here. We'll multiply top and bottom by its conjugate. What's the conjugate of 3 plus 4i? 3 minus 4i. That's what I'm going to multiply top and bottom by. Now, because I know I can use my graphing calculator, I'm going to. So I times 3 minus 4i will give me my numerator in a plus bi form. Now I can also use that for my conjugate on the bottom. I just realized I was using my hand graphing calculator because I like to use that more. Sorry about that. I'll use my computer one from now on. Right, because 3 squared is 9 and 4 squared is 16 and 9 plus 16 is 25. So boom. I already should have known that. I was blindly moving forward. And there we go. Look at my coefficients. 4 and 3 and 25. Are they all evenly divisible by anything? Nope, you're done. That's what'll happen a lot of times. Not all the time, as we'll see in the next one. So the conjugate of 2 minus 8i is 2 plus 8i, and that's what I will multiply top and bottom here by. Remember, it's just the denominator that we need to rationalize, so that's where we pick our conjugate from, is the denominator. Alrighty, well, 2 squared is 4 and 8 squared is 64, so 68 should end up being my denominator. Up here, let's just multiply that. 2 times 2 plus 8i. And we get 4 plus 16i. Again, I could distribute that, or I could just do it in my graphing calculator. But what I do notice is now my coefficients 4, 16, and 80 and 68 are all evenly divisible by 4, right? So 4 divided by 4 is 1. 16i divided by 4 is 4i in the numerator. And 68 divided by 4, anyone know that? I hope someone's yelling. 17. And there's your answer. You do have to simplify if all your coefficients can divide evenly by something. So you do have to actually do that simplification if that comes out. So always analyze your coefficients before you're fully done. All right, last one. I could simplify that I squared in my numerator first, but instead I'm just going to take to my conjugates, which the conjugate of negative 2 minus I is negative 2 plus I. And that's what I'm going to multiply top and bottom by. So in the denominator, negative 2 plus I and negative 2 minus I. 5. Cool. All right, in the numerator, 3i squared times negative 2 plus I. So I wrote it out so I knew I would have the conjugate correct, right? And I get 6 minus 3i up there. Now let's look at my coefficients. 6 and 3, they can both divide evenly by 3, but my denominator 5 cannot. There it is. Whew. Now we'll note that all of those rationalizers, they had single terms in their numerators. But we know that it's not going to stop there. We know how this goes. We know that's why there's another page. Binomials in the numerator as well. Let's go. So what's my conjugate of 1 plus 4i? That would be 1 minus 4i. And, well, here I can just do 1 squared is 1 and 4 squared is 16. So my denominator is going to be 17 here. Because sometimes you guys don't believe me on this stuff, even though I don't know why you don't believe me. Come on. Give me my props while you're at home. 3 plus I and 1 minus 4i. 7 minus 11i is my numerator. Notice that was foiling, right? But I kind of skipped that step where I showed all that FOIL because I know I can type this into my graphing calculator and go straight to that answer. So I did. Now let's analyze our coefficients, 7 and 11 and 17. All prime, by the way. All prime. So we're done there. It won't always be the case, but there was a place where that was the case. Now, what you need to be careful of when you've got binomials in your numerator and denominator is make sure you're doing the conjugate of the denominator. So I don't care what the numerator is. What I care about is what's the conjugate of 3 minus I. Well, it's 3 plus I. So that's what you multiply top and bottom by. Okay. So again, this is 3 squared is 9 and 1 squared is 1. So 3 plus 1, or excuse me, 9 plus 1 is 10. That'll be my denominator. And up here, that is FOIL, but we can just type that sucker in. So 4 plus 2i times 3 plus I gives me 10 plus 10i. Oh, this will be interesting. Huh? Because 10, 10, and 10 are all evenly divisible by 10. So let's divide. 10 divided by itself is 1. 10i divided by 10 is a 1i, or just an I. And in the numerator, in the denominator, 10 divided by itself is a 1. Do I have to write a 1 as a denominator? Heck no. You're done. There we go. Nice. That could divide. We like it. Even a plus bi form. Our graphing calculator still does a plus bi form, guys. Amazing. Okay, last one, and then I'll let you start to practice. The conjugate of my denominator here, the conjugate of 1 minus 2i is 1 plus 2i. So I do that top and bottom. And let's see. So 1 plus 2i times 1 minus 2i gives me, 1 squared is 1 and 2 squared is 4 and 1 plus 4 is 5. So I really should have known that, huh? On the top. Not going to be quite as fun as that, but let's see how we do. So I'm taking my numerator, multiplying it by my denominator's conjugate, and I get 15 plus 10i, a plus bi form. That's what's the beauty of that graphing calculator. Ooh, 15 and 10 and 5 are all evenly divisible by 5. 15 divided by 5 is 3. 10i divided by 5 is plus 2i. And 5 divided by itself is 1. So do I need to write that? Heck no. I can stop right there. Can you? Can you write 3 plus 2i over 1 as your final answer? Sure. These two things are equivalent. Am I going to? No, I am not. And there we have it. Last joke of this lesson for, I have a shirt with this on it. At some point during my videos, I will wear this for you. But be rational, get real. Ha! So much fun, guys. Fun guy, right? There's a science one. All right, anyway. Guys, let me know if you need anything as you are doing your chapter 5, lesson 4, notes day 2. But I think you should be okay. If not, let me know. Email me. I will help you. and I shall be seeing you. Bye, math analyzers.